Hello friends, this video on probability 5 is brought to you by examfear.com. No more fear from exam. Before watching this video, you should have watched probability part 1, part 2, part 3 and part 4. So now we'll solve some card problems on simple probability. A card is drawn, one card is drawn from 52 cards and everything is equally likely. All the outcomes are equally likely. That means the probability of a black A is same as the probability of red A. Calculate the probability of diamond. So when I say diamond, how many diamonds are there? 30. Right? So probability is equal to, if you see, favorable FAB events by total events. So if you see in this case, in the case of 1, FAB event is equal to 13. There are 13 favorable events, 13 diamonds, and total is 52. So the answer is 13 by 52, 1 by 4. So the probability for a diamond is 1 by 4. Probability for not an ace. So not an ace, how many aces are there? 4. How many are not ace? 52 minus 4 is equal to 48. So in this case, the probability of not ace is equal to 48 by 52. Third, a black card. How many black card? Black card 26. Total number of cards 52. So the total probability is 1 by 2. The probability of black card is 1 by 2. Similarly for red card also, probability of you find the red card. Red card is 26. Total card 52. Total probability of red card is 1 by 2. Probability of not a diamond. How many not diamond? Or we'll first find probability of diamond, we'll subtract. So probability of diamond is equal to, there are 13 diamonds. You see 13 diamonds. 13 by 52 is equal to 1 by 4. So probability of not diamond is equal to 1 minus probability of diamond is equal to 1 minus 1 by 4 is equal to 3 by 4. Similarly, the fifth one, probability of not a black card. So not a black card, first find probability of black card. Black card, we have already found this 1 by 2. So probability of not a black card is equal to 1 minus probability of black card, and this is equal to 1 minus 1 by 2 is equal to 1 by 2. So if you see also, it makes quite simple. Either it is a black card or red card, 50-50. So probability of black card is 1 by 2. Probability of red card is 1 by 2. This is an item draw problem wherein some items are drawn from a bag. So this bag has 9 similar discs and 4 are red, 3 is blue and 2 is yellow. A disc is a disc. One disc is drawn at random. Calculate that it will be a red. Probability it will be a red. So for probability of red, total number of red is 4 and total number of disc is 4. 4 plus 3, 7 plus 2, 9. So it will be 4 by 9. Favorable event by total event. Similarly, for probability of yellow, yellow is 2. Yellow is 2 here, 2. 2 by total is 9. Similarly, probability of blue is how many? 3. So it will be 3 by 9. Probability of not blue is equal to 1 minus probability of blue and equal to 1 minus 3 by 9 is equal to 6 by 9. Now probability for either red or blue. So probability of red or blue is equal to probability of red plus probability of blue minus probability of red or blue. So red is equal to 4 by 9, blue is equal to 3 by 9, and there is no common element. If it is either red or blue, it can't be both red and blue. So it is 0. So the answer is 7 by 9. So what we have done here is probability, as we know, is favorable event by total event. So we have used this formula. Favorable event is 4 because they are 4 red by 9. 9 is total. Similarly for Y, favorable is 2, they are 2, 9 is total. For blue, favorable is 3, 3. That's how we found the answers. Let's take one example. This is a little tricky. So two students A and B appear in the examination. The probability that A will qualify is 0.05 and B is 0.10, and both will qualify as 0.02. Find the probability that both A and B will not qualify. So let me first write what I mean. Probability that A qualifies, that means probability of A, P of A is 0.05. When I say probability that B will qualify, that means P of B is equal to 0.10. When I say both A and B will qualify, that means probability of A intersection B is equal to 0.02. Now, when we say both A and B will not qualify, right, that means we are asking for probability of both A and B qualify and complement. Complement of both A and B not qualify. Because if you see A and B not qualify, this will be this area. This area. This area. Because this is A, this is B, and both in this area only we'll see A and B are not qualifying. And this is denoted by A union B complement. So we have to find A union complement. First find A union B. So probability of A union B is equal to PA plus PB minus P of A intersection B. So this is equal to 0.05 plus 0.10 minus 0.02, and this comes out to be 0.13. Now when we want to find P of A union B intersection, what we get is 1 minus P of A intersection B, and this is equal to 1 minus 0.3, and this is equal to 0.87. So this is the answer for option number 1, A. Now let's go to the second option. At least one of them will not qualify. When I say at least one of them will not qualify, what I'm trying to say is this whole area. Because in this area also you see, right, here both of them are qualifying, and here at least one, here none of them. That means at least one of them will not qualify, means 0 will not qualify or 1 will qualify. So these are the area, and this area is nothing but P of A intersection B ka complement. So let's do this in the example here. So when we say P of A intersection B complement, this is equal to 1 minus P of A intersection B, and this is equal to 1 minus 0.02 is equal to 0.98. So this is the answer where at least one of them will not qualify. Now take 3, C. So in C we say only one of them will qualify the exam. So when I say only one of them will qualify the exam, I am looking for which area? This area. This is 1, and here also only 1. Please note, we are not looking at this area because here both are qualified. We are looking at only this area. So this area we can also write as P of A union B, that is total, minus P of A intersection B, right? This is P A union B whole. If you minus this vacant portion, you get only this two. That's what we are doing. And we already have the values of P of A union B, that is 0.13 from the example, and this is 0.02. So we get 0.11. This is the probability of this area. Now let's take some probability example with combination. a committee of 2 people has to be selected from 2 men, 2 women. What is the probability that it will have no man? So it will have 0 man and 2 women, case 1. So probability of this is, we have to find 2 only. So we don't have option other than selecting 2C2. From 2 women we are selecting 2. Divide by total probability. How many people are there? 4. 2 plus 2. 2 men, 2 women by 4C2. This is the favorable event. This is the total event. What you get is 1 by 6. 0 men, 2 women. Favorable event by total event. Total event is 4C2 because there are 4 people, and out of 4 we have to select 1 man is selected. It is 1 man plus 1 woman. So here when you say PE, it will be 2C1 because 1 man is 2C1 and 1 woman is 2C1. The whole thing, when you divide by 4C2 with the total event, we get 2 by 3. And this is the probability where 1 woman and 1 man is selected. Now the third case is 2 men. That is 2 men plus 0 women. So here also if you see is equal to 2C2 is the men, divide by 4C2, and this is equal to 1 by 6. So these are the answers. So let's discuss probability of selection. In this example, a letter is to be chosen at a random from word association. We have to say whether it is a vowel or consonant. We have to find the probability actually. So let's first categorize this into vowel and consonant. Okay, A, S, S, A, S, I, N, A, T, I, O, N. We have now categorized the word into vowel and consonant. So this is 3, this is 2, this is 4, this is 2, this is 1, this is 1. So now a word is chosen from this letter. The total combination, because we are selecting here, total combination is equal to 13C1 because they are 3, 6, 5, 6, 10, 12, 13. There are 13 letters. So total sample space is 13. Now probability of V, if you say, how many was there? 3 plus 2, 5 and 6. So out of 6 we select 1. This is the sample space. This is the favorable space. Divide by 13C1. So this is my probability of vowels. Similarly, for probability of consonant, we have 7 consonants. So from 7 we select 1. This is the favorable event. And from 13 we select 1. This is the whole event. And this is the probability for consonants. So this comes out to be 6 by 13 and this comes out to be 7 by 13. So if you add these, you see you get 1. So the number is either vowel or consonant. Thank you. Visit examfear.com to watch free educational videos, try free online test, get the best quality study material, study from the best tutor and mentors, and much more.